Welcome to the lecture series of Analog Electronics. In today's session, we are going to see about small signal analysis of BJT in common emitter configuration. There are two kinds of small signal models. One is called as RE model, which is drawn as the basis of the emitter's internal resistance. It's also called as pi model. The other thing is H parameter model. The commonly used one is H parameter model. I have drawn the H parameter equivalent circuit of the BJT in common emitter configuration. This is the emitter terminal, which is made as common for both input and output. The input is the base here and the output is the collector terminal. The output current is termed as collector current, which is opposite in the direction of the load current. So the four H parameters are HIE input resistance and HRE reverse voltage ratio, which is and HFE forward current gain and H0E output admittance. So as per the H parameters equations, the equations for the input voltage and output current are written here as Vi is equal to HIE IB plus HRE V0. This is the first equation of H parameter, and second equation is termed as output current equation. Here the output current is termed as collector current. So IC is equal to HFE IB plus H0E V0. This is the second equation. When we want to see the small signal analysis of common emitter amplifier with the H parameter model of the common emitter configuration, just we have inserted the source resistance RS as well as the load resistance RL. Source resistance is connected through the voltage source. This is the current limiting resistance of the voltage source. And Vs and Vi are different voltages. Vi is the input voltage. It is the voltage drop across volt or voltage supplied across the base and emitter terminals. This is the base terminal and the common terminal is the emitter terminal. And Vs is not equal to Vi. There is the series resistance Rs, which is giving the difference between Vs and Vi. Vs can be written as Ib into Rs plus Vi. This is one important equation. And second one is at the outside at the output part, we have connected the load resistance RL. The voltage across the RL is V0. As there is no series resistance in the output circuit, V0, the output across the load is equal to the output across the BJT. So V0 is equal to the collector terminal voltage Vc, which is equal to minus of Ic into RL, because the IL and the Ic are opposite in the directions. The direction of IL and Ic are reversed. So IL is flowing through RL in this up to down top to down direction, whereas Ic is into the device. So Ic is equal to HFE into IB. When we are doing the analysis of common emitter amplifier, we need to find four different parameters. One is the current gain, another is the input impedance, third one is the voltage gain, and fourth one is the output admittance. So the current gain is referred as output current by input current. Here this output current is collector current and the input current is base current. The I0 is, that is the load current, is always referred as the output current. Since the load current and collector current are in opposite direction, it is taken as minus Ic by Ib. The AA is taken as minus Ic by Ib. And input impedance is input voltage by input current. So input voltage is referred here as Vi. It's not equal to Vs. We have taken the voltage across base to emitter terminal. So this is Vi divided by base current Ib. And the voltage gain VAV is equal to V0 by Vi, output voltage by input voltage. Output voltage is equal to the collector voltage and input voltage is the voltage supplied at the base terminal. Output admittance is taken as the reverse of the output impedance, inverse of the output impedance, which is equal to I0 by V0. As we know, I0 is nothing but IL, which is equal to minus of Ic divided by V0. V0 is the output voltage. The current gain is the derivation for current gain. A is equal to minus Ic by Ib. When we take the we can take the second equation of the H parameter equation, which relates the output current. So IC is equal to HFE into IB plus H naught E into V naught, whereas H naught E is the output admittance, HFE is the forward current gain. So substituting the value of V naught is equal to minus IC into RL. Substituting it, it can be written as HFE into IB plus H naught E minus IC into RL. So collecting the IC together, we will get IC is equal to 1 plus H naught E RL, which is equal to HFE into IB. So the ratio is taken as IC by IB, which refers to HFE divided by 1 plus H naught E into RL, which is also known as the current gain equation. And the second part of the equation, or second parameter what we need to calculate is input impedance. Zeta is equal to Vi by Ii. Ii is nothing but the base current, so it's taken here as IB. We will recall the first equation of H parameters. For H transistors common emitter configuration, the H parameter first equation can be written as Vi is equal to HE IB plus HRE V naught. Vi divided by IB will give you HIE plus HRE into V naught by IB. This is the base current IB. So V naught can be substituted as minus IC into RL, and IC by IB is already known as current gain. So substituting all these things, we will get the Zi is equal to HIE plus HRE into AI into RL. We can also substitute the value of AI here, so we will get the final equation for the input impedance as HIE minus HRE into HFE into RL divided by 1 plus H naught E into RL. This is by substituting the AI value in ZI. The third parameter is voltage gain. Voltage gain is output voltage by input voltage, which is equal to minus ICRL divided by IB into ZI. So as we all know about this minus IC by IB, that is nothing but the current gain. That can be replaced by writing the value of AI into RL by ZI. AI is also already calculated, ZI is also calculated. So this is the first parameter and this is the second parameter. So we can substitute those values while calculating the voltage gain. The fourth parameter is the output impedance. Output impedance is equal to Y naught is equal to I naught by V naught. I naught is nothing but the output current, which can also be referred as IL by V naught or IC by V naught. Here we give the important condition as Vs is equal to 0, because amplifier in amplifier, whenever you are supplying the input, we will be getting the output. So we can write the input and output voltage equations like this. The V naught is always proportional to the input voltage, where the proportionality constant is referred as voltage gain. AV is equal to V naught is equal to AV into Vi. So if there is any input is supplied, any input voltage is supplied, that affects the value of the output voltage. So when we want to calculate the output impedance of an amplifier alone, we need to make Vs is equal to 0, or the input should be taken as 0 volt. Right. So we have modified the circuit, and I have drawn the circuit here like this by taking Vs is equal to 0. That is directly Rs is grounded. There is no supply, or there is no supply input. Now by applying the KVL to this input loop, this is the input loop and the current flowing through this is your IB. By applying the KVL to the input loop, we will be getting Rs plus HIE into IB plus HRE into V naught is equal to 0. So by making the mathematical rearrangements, we can get IB is equal to minus HRE V naught divided by Rs plus HIE. So V naught can be taken to the denominator part, and IB by V naught will be taken like this. So this is one important equation to find the value of output impedance. And we know that Y naught, output impedance, is IC by V naught, and this is the current equation, second equation of H parameter. Second equation relates the IC value. Second equation of H parameter gives the IC value. IC is equal to HFE IB plus H naught E into V naught divided by V naught. So here we have in the second term V naught is getting cancelled. In the first term we have IB by V naught. This IB by V naught is already found by us by applying the input KVL. substituting that, we get this equation. Just rearranging this equation, y0 has been written as h0 minus hre into hfe divided by rs plus he. So now we have the, we could see the effect of rs, that is the source. We have taken, we have already assumed that Vs is not equal to the input voltage of the amplifier. So what will, if we include the Vs, what will be the value of AVS and AIS, that we could see. AVS is nothing but voltage gain with the source, So V0 by Vs, instead of V0 by Vi, we have taken it as V0 by Vs. V0 by Vs is equal to, we can just write this equation in terms of Vi by inserting Vi, V0 by Vi into Vi by Vs. This V0 by Vi is nothing but AV. This is the voltage gain, that is the third parameter what we have calculated. So Vi by Vs can be taken from the voltage division rule. This can be taken from the voltage division rule. By applying the voltage division rule, Vi can be taken as Vs into Zi divided by Zi plus Rs. So substituting this AVS, voltage gain with the source, can be written as AV into Zi plus Zi plus Rs. Similarly, we can also calculate the current gain with respect to source by applying the current division rule. By applying current division rule, input current can be written as the supply current into opposite resistance divided by the total resistance. So AIS can be taken as AI into Rs divided by Zi plus Rs. So by concluding all these things, for the CE amplifier, we have found the four parameters: the voltage gain, input impedance, current gain, and the output admittance. The equations are summarized here. You can also calculate current gain and voltage gain with source, that is called as AIS and AVS. By applying the voltage and current division rule, we can obtain this. And there is another simplified value of this, which we call it as approximate analysis of H parameter model. So in the approximate analysis, two H parameters are getting neglected. This is HRE, reverse voltage gain, and H0E are neglected. Usually the value of HRE and H0E are in terms of very less value, it's negligible value. So we assume that HRE is equal to 0 as well as H0E is equal to 0. Usually this will be in terms of micro 10 to the power minus 6, and this is in microamps per volt. H0E will be, so we can neglect this mathematically, and it can be taken as A is equal to minus HFE. By neglecting H0E, we will get it as HFE divided by 1. So A can be simplified as minus HFE. Zi can be taken as HIE minus HRE into this value. So HRE is taken as 0, 0 is multiplied by anything. So you will get Zi is equal. These are all the approximate analysis. So it's all equated to the H parameter values as an approximation. AV can be calculated from AI and Zi. And Y0 is taken as H0E. As H0E is neglected, Y0 is very less, or in terms, we can tell in terms of R0 or Z0, that is the output impedance is 1 by 0, which is also equal to infinite value. So this is the important parameter or important characteristics of an amplifier. Thank you. With this, we will be concluding the small signal analysis of common emitter amplifier. Thank you.